Okay, picking up where we left off on page 421, we're talking about fault-tolerant servers and how they have dual power supplies and fans and things of that nature. There's another way you can do this, and that's with what's called dynamic hardware partitioning. And if you remember from a previous chapter or two, we talked about virtual machines, where I can have a machine inside another machine. And so I can allocate resources to it. I can say, well, you have 2 CPUs and you've got this much RAM and whatever. So you could have one of those sort of as a standby. And if one of them failed, you would just allocate more resources to it. You could say, oh, now you have 4 CPUs, and oh, now you have 16 gig of RAM. And so you just kind of turn the knob and boost the ability of a cloud-based or virtual kind of a scenario. So yes, the virtual machines and cloud-based machines are the only way you can really get away with this hardware dynamic partitioning. So basically it's about increasing and decreasing the hardware resources on demand. That's what it's about. The cool part about that is, like these things, there's no human intervention. If something goes wrong, it automatically just switches to the other machine. So same way with this. If I had multiple machines and they all were configured for this dynamic partitioning, and then this one just died, okay, the other guy, it doesn't matter why, the other guy would say, whoa, I'm certainly getting a hell of a lot more traffic than I used to. And again, it doesn't matter why. It doesn't matter that it's Christmas time and there's a whole bunch of people hitting your website. It doesn't, or this other one died. It doesn't care. It says, whoa, I need more. So it ramps up how much CPU and how much RAM and how much network resources that it can take. So this dynamic thing is actually pretty doggone cool. All right. Now, you can just use normal, ordinary hardware. You don't have to go buy fault-tolerant hardware in order to pull this off. So some people do this because it's a lot cheaper. So you can take what's called make a cluster of just ordinary servers or ordinary PCs. They don't have to be super-duper fault-tolerant. And so the way this works is I used a piece of software that kind of runs on all these guys. So I have a handful of ordinary servers that are not fault tolerant, and I have a piece of software that kind of does like a heartbeat, listens to the heartbeat of all the servers, and if one of them has a cardiac arrest, well, then it automatically switches over the resources to the other guys. And so it's not quite as good as having fault tolerant guys, but it is scalable. I mean, I could have it with 4, or I can have it with 8 and 16, just keep on going, however many these things. And it's going to be cheaper because, ordinary PCs are a heck of a lot cheaper. So this is where the thing of load balancing comes up. So for example, let's say I had a website and I want to have 2 servers to handle the load. Well, how the heck do you direct traffic so that the load on this server is essentially the same as the load on that server? How's that done? Interesting, huh? Like, maybe there should be a writing assignment on that. But anyway, so there's some tricks you can use to direct the traffic to this guy. You can do a round robin. Okay, the first guy goes to here, and the second request goes to here, and the third one over here, and the fourth one over here. You just go through. There's lots of different ways you can do that. So that's using software to increase reliability. Okay, cool. Replication. So if I have ordinary PC, I probably want to periodically make copies of that. So if something died, I could just replicate the whole thing over and reproduce the machine someplace else in a heck of a hurry. So being able to have like complete backups of everything, have replication of hard drives. So if I have an ordinary hard drive that's not necessarily super duper, I can put a second one in, and everything that writes to over here also gets replicated over there. Kind of cool stuff. Later we'll talk about how this works in a database world where you do database replication. Kind of cool. So the focus of this hardware architecture is, believe it or not, is not necessarily performance. I mean, I know that sounds a little weird, but when you're trying to design a high availability thing, the price versus performance thing, okay, a good way of describing it is, I could design a sports car and it would be very, very fast, but only for 2 people. If, on the other hand, I use a city bus, I could, haul 30 people. So, which is faster? A sports car or a city bus? Kind of sort of depends, right? If you're trying to move a lot of traffic, it's that low cost, city bus is going to work. So, most people, the dollar amount, how much you're spending on this thing. So, for example, when you go get a high availability server, it's probably not going to have the most robust, fastest CPU on the planet, the fastest RAM on the planet, the fastest graphics card, the fastest hard drives. No. It's going to have ordinary run-of-the-mill CPU, ordinary run-of-the-mill, components, because those ordinary things that aren't pushed to their limit are going to last longer. Running these things at super duper high speeds at the limit of technology, on the bleeding edge of technology, invites more failures, okay? So, my ordinary machine that I have at my desk probably has a faster CPU than the CPUs in these servers. Okay, that's the whole point. In other words, dollars kind of sort of overran the performance thing. They don't go for bleeding edge. They go for, you're going to have to buy 16 of these servers. So they can't be premium. They can't have super duper premium parts in there. Top of the line everything. No, that's not going to happen. Okay. So we talked about architecture. So on page 423, we talk about high availability applications. So obviously we're talking about being done at the application level. Sometimes people call this the middleware level. Because you could have software that, a software over here and software over here, and you have to have something that kind of bridges in between. So databases is a classic example of where you can have software high availability. It is not unusual, for example, for a database to, when a database transaction comes in, it gets stored in one server, and then a message gets sent to another server to do that over again. And that way you end up with 2 identical copies of things. So there's an example here of this cluster manager, sort of like, again, middleware. So I have, a location. So out at my main branch, I have an application server A and application server B. Cool. But then across town at a different building. Why a different building? Tornadoes, floods, fires, right? I don't want to have my backup copy inside the same building. Because if I had a fire or a tornado and it wiped out the building, I would have nothing. So we're definitely talking about physical separation here. And there's some math that people apply to try to figure out how far these things ought to be. Like there's a little map of the U.S. If you're in an earthquake zone, you're in a zone that's prone to, hurricanes, then the distances are huge. But if you're in ordinary parts of the country, well, the distances are, probably the width of a tornado if you're in a tornado alley. If you're someplace else, it's, it's fires and all the rest of the things. So anyway, there's some people that do an awful lot to figure out how far away these things need to be. So I have location number 2 and some sort of a thing that manages all this. So I have, let's say I'm a bank, okay? In a bank, I absolutely positively cannot lose any transactions, okay? For example, let's say I'm moving money from one account to another, okay? And I pull $100 from one account, and then dang, the power goes out. Well, I don't ever want to be stuck where I removed it from one account but didn't put it in the other account. In other words, those transactions have to be atomic. That's a database term, where it's all or nothing. So when I take that transaction and process it over here, there is 2 ways of thinking. One is I'll immediately tell you that it's successful, and then behind the scenes I'm going to send that transaction over to this guy and have him do it over again. That way these things are always duplicated. That's one technique. But if I'm really, really paranoid, I'm a bank and I'm doing financial transactions, when I do this first transaction, it's going to say, hang on a second, and it's not going to return until after it gets replicated. And after it gets replicated, it's going to say, thank you for your business, we're done. Okay, so there's two different ways you can think about this. One is the the type of mirroring that says, I'm not going to finish until all partners agree that we're done. That's one way. Or the other technique is a little bit faster but a little bit scarier, is that whoever the first one who says they're done, I'm going to go ahead and tell the client that they're done. So one is fast but scary, the other is slow but safe, and you get to pick how you set this thing up. Okay. Back to the whole thing about the failover cluster. If this guy failed completely at the database level, then I have to have some way to switch over to the other guy. So I have to have some way of making sure that this machine database is in synchronization with this guy, so that if this guy dies and I switch over, you are not going to miss any transactions. So it has to be able to catch like transactions that are halfway done and then remember them and then transmit that halfway done one over here, because this guy died. So it's a heck of a lot of work involved. But don't worry, you don't have to do any of this. The database servers know how to do this all by themselves. Basically, the idea is they clone the database all the time, and they break these things up into discrete things. It's called state, where the state of the machine is always known, and I can queue up changes to that, and if it dies, I'll just take that queue and move it over to the other guy, and it picks up where it left off. Okay, cool. So let's say the distance between these guys is, I don't know, 1,000 miles. Okay, you've got someplace in California, and you're trying to put it in Arizona or someplace. There's going to be some significant delays in here, right? I mean, I'm probably not gonna be running a fiber optic cable of my own. That would be terribly expensive. I'm going to be shooting this through the internet, and so there could be 20 or 30 milliseconds, maybe 100 milliseconds difference between latency between these two sides. Is that okay? Those are the kind of conversations you have to be, because every transaction is eventually going to be replayed, and so it's a matter of how much of a delay time is worth to you. I know companies that have spent millions and millions to reduce this delay, particularly if you're doing financial trading on the stock markets, where, I want duplication going on, but I certainly don't want to slow down a transaction any. So they spend lots of money to have another server that's maybe half a mile away be their backup. They don't do 1,000 miles. They do like a mile away. Okay. So they can run their own fiber optic cable, and they can get 1 or 2 millisecond of latency. Okay, on page 426, they talk about the high availability at the operating system level. Ordinary Microsoft server, ordinary Microsoft Windows has some ability to do high availability, some capability of doing high availability. But when you go into the enterprise versions of server, then it comes with all this clustering things built in. So if you buy standard server, you don't get much. But if you go up a couple of notches on their SKUs, you'll end up with buying a version of Microsoft Windows that's specifically designed for clustering. And it already has the stuff built in for keeping heartbeats and keeping all this information synchronized. So it's all built in. You don't have to do anything. You just need to spend more money on the enterprise versions of Windows. And unfortunately, this is probably a good place to stop for the 15-minute mark.